Yeah, I'm going to be talking about creating D3 components. There we go. I'm quickly going to cover D3, data join, which is kind of the fundamental concept in D3, what a component is in D3, and kind of our experience of using components. First off, a quick show of hands. Who's actually heard of D3 before? I want to say that was most. And who's used it before? Well, probably half. All right. So this first bit, if you already know what it is, hopefully it doesn't last too long. I've given myself 2 minutes. Let's see how we get along. So I like to think of D3, first of all, one of the building blocks of it is jQuery-esque DOM abstraction. So in there, you've got helper methods for selecting nodes. Hopefully you can see that. You've got kind of manipulation. So the standard stuff, changing the inner text, setting styles, all of that malarkey. You've got event handling, so namespaced event handlers. And you've got an Ajax abstraction. And you've also got support for doing transitions and animations, which is good, because most people use it for doing jazzy visualizations. Another big part of it is layout algorithms, and an example of that is scales. So scales are like the building block of axes. The scale converts from a data domain value into a pixel domain value. You've got specialized layouts. So this is a helper which, if you're creating a pie chart, you might use it. You give your data to it. It gives you back angles for the pie chart. Oop. Got some geometric primitives, and you've also got some geographic projections, but I've not really used either. You've also got SVG helpers. D3 can be used with any type of DOM. It doesn't have to be used with an SVG DOM, but if you are using it with SVG, then it's got some helpers in there. For example, if you want to render a scale in SVG, then an axis leaves all the algorithmic complexity within scale, but is an SVG renderer for that scale. Similarly, you've got helpers that help you with the SVG paths, and you've got kind of miscellaneous other stuff like time formatting, which is very useful for scales, and plenty more. So I can explain D3 without showing some examples. So this is kind of bog standard chart you get out of any library. What you might not be expecting from D3 is, there we go, you get this kind of wacky stuff going on. So this is kind of a force-directed graph that you can get out of it with some collision detection. And then you get just nutty stuff I don't really understand. So yeah, fundamentally D3 is built up of data binding, which is the bit I've yet to cover, DOM abstraction, layout algorithms, SVG helpers, and kind of MISC. The key thing that's missing is there isn't a chart. There's no chart component in D3. So how do you kind of combine these things? Well, you do have data binding, so that's kind of the first step to building a chart with D3. So data join is data binding in essence. It's a unique concept. I haven't seen it elsewhere, but hopefully when I explain it, it will make sense and it will kind of mirror things that you've seen elsewhere. So data join is the idea that we want to take a bunch of DOM nodes in the bottom left, and we want to take the data at the top right, so the array items, and we want to render them into those DOM nodes. Now, first thing I want to say is that when you're doing a data join, you always want to try and make it kind of an idempotent operation. That means that for a given input data, the output should always be deterministic. It doesn't matter how many times you run your render loop, you should always get the same thing out as long as the input data doesn't change. Seems like a subtle thing, but you'll see we come back to it. Obviously, I don't actually recommend you put your render loop in a request animation frame. In this case, it would be pretty unusual. So first off, we do a selection. Data join is always built around a parent element. And then we select the nodes within that parent element. We need to take those nodes and we need to munge them together with the data. So the operation that does that for us is data, and it's available when you select all. Now, what is data actually doing? Well, data is taking the first DOM node, it's taking the first data item, it's munging them together. It's taking the second DOM node, second data item, munging them together, third data item, third node, merging them together. But there's no point doing that unless you do something useful with it. So in this case, we take those zipped up items and we say that this is called the update selection. The update selection contains each of these DOM nodes, and we're going to set the inner text of those DOM nodes to be like a templated string derived from the associated data, or the data item associated with that node. That's great, it's worked. Problem is, now we've come along and we want to shove another crew member in there. So we've added the item to our data array, but it hasn't shown up in our DOM nodes. So, like, where's it gone? If we think back to what D3 was actually doing, D3 was taking the first data item, taking the first node, combining them together. Second data item, second node, combining. Third data item, third data node, combining. Now it's got a fourth data item, but it doesn't have a node. So actually, I think in this case it'll error, but that's hidden by my example. But it'd be good if it didn't error. That's not ideal. So could we train it what to do in the case where it has a data item, but it doesn't have a node? And I wouldn't be asking the question if you couldn't. So in that case, you use the enter selection. So the enter selection is exposed on the update selection, and that's you basically associating a behavior when that situation occurs. So if we have a data item and we don't have a node, easy, we'll just add a node for that data item. That enter selection implicitly becomes part of the update selection, so then the node is templated, and we get Stranik showing up on the USS Missouri. So now what happens if we want to do the opposite? So the captain's been killed off, we've lost the first data item. Well, what are we going to do? Like, what's happened in the node, in the DOM list? And if you look in the DOM list, then yeah, we've got kind of what we expect. So the first three nodes match our understanding, but then we've got this random kind of duplicate node at the end. What's going on there? Well, again, going back to what D3 is actually doing, D3 is taking the first DOM node, the first data item, combining them together, that's what we see. Second DOM node, second data item, combined, that's what we see. Third. But then that fourth one, D3's got the situation where it has a DOM node, but it doesn't have a data item. So what should I do? What should D3 do? Well, in that case, we actually want D3 to remove the DOM node. And can you do it? Of course you can. So there you go. You use the exit selection on the update selection, and you just set the behavior to be remove the node. And if you haven't seen Under Siege before, they all die at the end. So, okay, so data join is an idempotent transformation of data into nodes. It's, again, come back to that, but it's really important. The join that we saw there was an index-based join. That's just one of the many types of join you can choose. You basically have complete control over it. It becomes important if you're doing things like animating and you want to ensure that a particular DOM node is always associated with a particular data item. And I suppose peeking under the covers of D3, what it's actually doing is associating that data item specifically with the node. And if you actually want to get access to it, you can do that. If you use selection.datum, that will return the first node within that selection's associated data. Okay, so as opposed to data join, I think data join is a bit of an abstract concept. Components, they're dead easy. Components are the unit of reuse within D3, and in the same way that components are the unit of reuse in D3, the unit of reuse in JavaScript is functions, so are they the same? Yes, that's all they are. A component in D3 is just a function that accepts a selection and operates on it. The only thing that looks kind of un-D3 about this at the minute is, you can kind of see here, this kind of nested calling of functions. It doesn't look very D3. Wouldn't it be nice if we could keep the same kind of chained fluent syntax for it? Of course we can. We can do it by using call. So this will have exactly the same effect. We end up with exactly the same end result. But the difference is we've kind of kept that fluid syntax, and it also explains why we don't have a return value. It would get ignored. So by convention, components are implemented as factories, which return an implementation of the component. That's only important once you want to have kind of instance-specific configuration within your components. And this is kind of just the D3 method for doing that. But you can see at the bottom, then we're starting to get something that looks more like the built-in D3 components. So component, it's the kind of convention-based unit of reuse. There isn't, it's not like we're invoking like D3 create component or anything like that. It's just pure JavaScript. The invocation of the components should be idempotent, and we should always try and make sure that our components are applicable to multi-node selections. So a multi-node selection that you want to use with a component might be if you have 10 SVG elements on your page and you want to associate 10 different data sets with each item, with each SVG, then when you went to render your component, you would want to use the local data associated with the SVG. You certainly wouldn't want it to use, say, the first one and render it across all of them. So that's a whistle-stop tour of kind of D3 and the core bits. Now I want to talk you through kind of 8 rules that we now try and follow when we're creating components in D3, and I suppose why we try and follow them. I've probably got less time than I hoped for, so I might skip over a few. But in 1, so we've seen data join and we've seen components. Obviously, you're going to be wanting to use the data bind concept in D3 within a component. You don't want to be re-implementing it. So it's exactly the same as what we've seen before. You can see it's a component which renders circles, and so then at the bottom where we're using it, we're passing in the radiuses of the number of circles we want created, and that basically gives us the DOM like we were expecting. It's exactly the same as what we've seen before. The only difference is we've kind of got this selection.each in the middle of it. That bit of code there is making sure that we are able to operate on multi-node selections. If we didn't have that bit of code, we could conceivably use the datum method that I mentioned previously, but we would end up rendering n different copies because we'd still be doing it for each input item, but we wouldn't be pulling the associated data. So you basically need to remember to use selection.each to get the associated data with nodes when you're creating components. So yeah, use each for usability, and it's also kind of demonstrating that you can choose whether it's most appropriate to do something when a node enters the DOM or when it's updated. The advantage of doing it when it enters the DOM is you won't do it every single time you loop through this. So it can be a performance thing, probably isn't, but it's a good way of making your intentions clear. So rule 2, this is a bit of a hack around the data join concept. So the only difference really here is you can see that's not me passing data in, that's me passing data as the first item in a new array in. By doing that, that guarantees that the array or the data will only ever contain one item, which will guarantee that we will only ever add one node to the DOM. So no matter how many times you call this component on a given selection, you'll only end up with one element in there. That can be hugely useful in certain situations. So for example, you're trying to add something that can capture mouse events. You only need to add one of those. You don't need to add n of those. The problem with it is people come to it and they think, I've got a good idea. I will use that to add a container to my element. So I will create all of my DOM nodes within that container. So you can see they're still doing a data join down here, but they're doing a singleton data join to create a root node for them. Basically, you're going to end up in gsoup, which is like the SVG equivalent of divsoup, where you've got Gs everywhere and you don't really know where they came from and they don't really serve a purpose. So the rule that we try to follow now is don't create container elements yourself. Always assume that your caller will, if it's appropriate, pass in a container element. The caller's always in a better position to make that call than you are. In order to allow that to kind of work and be composable, we make the promise that a container won't be reused. So if a caller passes you a container, you render into that container. If the caller wants to get rid of you as a component from the DOM, they will remove that container. That means you don't have to worry about kind of cleaning up any of your own state. Also, components are free to manipulate their container. So they're free to add event handlers, say, that kind of thing. And 4, key thing is not to maintain state in your components. So again, this comes back to kind of working with multi-node selections and also working in an idempotent way. So you don't want to it tends to happen accidentally. You don't want to kind of pull some state that's associated with a given selection and kind of maintain it at the component instance level. That'll cause you problems. So something that D3 does very well, and it's quite easy to miss, is that I gave the example before of it separating out a scale from an axis. An axis was just a rendering of a scale. A scale contains the algorithmic complexity of the component. This is very much an edge case where you would probably be quite comfortable keeping the algorithmic complexity within the component. And so the algorithm here is clearly that if you're an odd indexed element, then you will be given the fill attribute, even odd probably. I can't work that out. Maybe I'll go backwards. But it will paint between the two as it goes down. You could conceivably pull that into a separate component, but you probably wouldn't hear it simple enough. I couldn't fit a better example in, so my bad. But if you do start doing that, make use of rebind. Rebind allows you to, if you are using an algorithmic component, it allows you to take the configuration of the algorithmic component and expose it as properties of your component, which is really nice because it means that you can kind of hide the fact that you are using that other component, but still give the same flexibility as if someone was using that component directly themselves. This one's quite an obvious one. If you're familiar with kind of jQuery namespacing of events, it's always good to use them. It gives you more control over it. In D3, it's got the extra kicker that you're only allowed kind of one handler per type. So as soon as you bind one handler for a given type, you'll clear down the previous one. That's great for making kind of idempotent operations. You don't want n handlers everywhere, and you want your function to be allowed to be run as many times as possible. But it's not so great if you've got two components competing to add a click handler. So yeah, always make sure you namespace your events. The other thing is, if you are going to handle events, then always make sure you use custom events to re-expose kind of a higher level version of that event. This is really important for making sure that you can allow interactions with your component, which are the reason normally for using D3, you want to create an interactive visualization. If you've got it split up into components, you want to make sure that if someone interacts with your bit of the visualization, that can propagate throughout. Maybe it's a brushing behavior or something like that. And by doing it, you also you just increase the flexibility of your component. So to recap, keep it small and simple. If you're in doubt as to how maybe you should approach something, don't be scared to go and just look at how D3 approaches certain problems. They've got some weird conventions for writing their code, but you can actually kind of see through that with a bit of practice. And yeah, I suppose this sums up the joy, pain, frustration, all of it. Be really careful you're not recreating D3 or SVG functionality. I can list probably 10 examples where we've tried to do that without really realizing it. Specifically around like pixel snapping, that's something built into SVG, or like we built something that could do a stack layout for us, and that's captured by the stack layout component in D3. Don't know why we missed that one, but so I've kind of covered that what our experience is, but I didn't cover like how we gained our experience. So I think we picked up D3 and we decided that we would do what everyone else does when they see D3. We would rush out and we would write our own charting library on top of it. If you do a search for like D3 charting libraries, it'll be pages and pages and pages and pages. So what you want to do is, also what we wanted to do, we were like, they've got it wrong. The API they've got, it's really inflexible and it's not very quick to use. We're going to create an API that's both quick to use, dead easy to get started with, and also the most flexible API you could ever hope to use. So with those lofty goals, we set out to create D3 financial components. Obviously, I've got a financial bias. So there are certain things that aren't captured within D3 that are useful for financial charts. So things like candlestick series and open, high, low, close, and blah, 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 blah. So yeah, it was going to be this amazing toolkit and one charting library to build them all. But I don't think it's a surprise to anyone that we didn't achieve that. And all we really did is kind of find out that these guys do know what they're doing. And if you're making a charting library, it's dead easy, or you've basically got to make a choice when you come up with your API. Your API is either very easy to get started with, it's very quick to create a chart, or it's hugely flexible. And that means it's a nightmare to get started with. So you need to pick somewhere in between, and you're also like trading that off. Every bit of flexibility that you add kind of bloats your components. Sorry. So yeah, we basically decided that's not going to work for us. So we've come up and we've basically embraced the D3 simplicity, prioritization of simplicity. Lots of small little components. So we now kind of consider a curated and consistent set of examples rather than components that you would necessarily directly build upon. And the key difference is that whilst you are able to take our components and make something very quickly with them, they are flexible to an extent. But if you want to take the component and it doesn't quite do what you want, just copy and paste it. All the components are very, very small. They're all composed. So the maintenance burden of copying and pasting it shouldn't really be that high. We think that's a little bit more like how the D3 mindset should work. We're still not sure if we're doing it right, but it's working for us at the minute. So that's it. It's up on GitHub and NPM, so please feel free to check it out. And yeah, that was a journey of pain, joy, frustration, and enlightenment creating D3 components.